Hello guys, welcome back to my YouTube channel. In this video, I will tell you about BWTS, Ballast Water Treatment System. So I will share you the system which is installed in my ship. So you will get an idea that how this system works. And this system is very popular because easy to use, and the operation wise it is more convenient because it doesn't give too much of trouble. I think near about 7 to 8 months back it was installed on my ship during dry dock. So right now it is working properly. Sometimes it gives problem, but in this video I will not talk about the problem. I will only talk about the operation of BWTS, how it works and what things are there, what machineries are there. Nowadays the ship which is going for dry dock, they have to install it, no option, because the rule is mandatory. So they have to install this ballast water treatment system. This is basically for the operation of ballasting and deballasting. So these plants are installed so that we should not mix this specific species of a particular area with other species. When we go with the ballast water treatment system, all those species which are small microorganisms which are there in the water, when we do ballasting, we generally remove them or filter them out so that they should not be there in our ballast tanks. So once we do our deballasting, once again they are filtered and checked that the level is maintained, so that when we discharge this ballast water to the sea, mixing of microorganisms should not be present. So guys, this side you can see BWTS plant. On my ship, the BWTS plant is from the maker of Sunrui Balclor. So the equipment which are present in these are AFU filter, your rectifier unit, EDU unit, ANU unit, you have a heat exchanger also, and you have a seawater booster pump and pre-filter for EDU unit, and 2 sets of TRO, one in engine room, one on deck, and two display unit which is your HMI, one in engine room and one in CCR. You have a hydrogen sensor also, and many other sensors and pneumatic operated valves. All these things help us to run this BWTS plant. We'll see one by one that how this equipment comes in role in ballasting and deballasting process. On my right you can see automatic back flushing filter unit, also called AFU. So this one is there in midship. This AFU, automatic back flushing filter unit, you will find on deck. We have a separate BWTS room on deck. So this filter unit you will find on deck. This side you can see this is a rectifier unit. This is your seawater booster pump which takes suction from sea. This unit is your electrolytic disinfection unit or your EDU. This unit is your automatic neutralization unit, or in short you say ANU. These are all your control system and power cabinets from where all blowers and your motors are having connections. So these are the electrical boxes which are present on my right. This is a human machine interface unit which is present in engine room. This is the one which is present in CCR. Using this CCR or engine human machine interface, this is a touch screen. From here you can give the command, and accordingly this control system comes in role, and these filter unit and the ballasting and deballasting take place. This is your TRO monitoring system. They are having 2 sets of TRO, one in engine room, one on deck. These blue color valves, you can see this is a flow meter, this is a flow meter sensors. So guys, this screen you will find in ballasting process, and this screen you will find in deballasting process. So in this screen you can see the system is running in normal. By clicking on the alarm list, you can see the list of alarm which is present, and you can acknowledge or reset the alarm also. You can see all the readings are showing in this is a touch screen which is showing all the reading. You can see your rectifier readings, you can see your differential back pressure reading, or your TRO reading, or which valve is open, which valve is closed. This green color, your valves are open. So this is a very small cabinet from where you're going to control it. There are 2 operations in BWTS, ballasting and deballasting. Ballasting is a case when we take sea water, we fill our ballast tanks to balance the ship stability and to maintain the draft. These ballast tanks are present just to the end of each cargo tanks, facing toward our sea. So if I talk about from outside, first the ballast pump comes and then our cargo pumps. To maintain the stability and the draft of the ship, we have to do ballasting and deballasting. Ballasting is a process when we take seawater and fill our ballast tanks. Deballasting, while filling up the cargo, we have to empty these ballast tanks. So while ballasting, these seawater pumps, they automatically come in roll. Your seawater boost pumps are typically your centrifugal pumps fitted with standard motor. If I talk about ballasting, during ballasting, automatic back flushing unit comes in role, your rectifier unit, your EDU unit, and your TRO unit. TRO basically sends the reading. While ballasting, the reading should be in between, in this range. If the reading is not in this range, your PLC controller will sense the TRO reading and it will give command to the rectifier unit to increase more current so that the electrolysis take place in a proper manner. If I talk about ballasting process, your ballast pump will take suction from sea and this seawater will get filtered in your AFU, automatic back flushing unit. Guys, this is your deck unit and this is your AFU. This is your TRO unit, filtering pump. Sensor, and then this going to this wall. This wall is having my indication. You can see here, this is open, and this is going to AFU. Sorry, they have printed it. This is your differential pressure switch, and this is your AFU outlet. Our pressure sensor is connected. Ballast tank suction, port and starboard, which is going there, and then this going to this AFU filter. After filtration, it is going like this. You can see. This is your seawater booster pump. Basically, it takes suction from seawater and feed to pre-filter of EDU unit. You can follow this red marking for piping. After the seawater booster pump, the water will go to EDU unit and the filtration process will be done. This is your AFU control box which control this small pre-filter for EDU. So look wise this is smaller, but the function wise this is similar to the bigger AFU which I have shown you in the midship store. So the discharge of this AFU filter, you can see the red arrow, the outlet will go to your EDU unit. So you can see the marking, red marking, this pipe is going to your EDU, electrolytic disinfection unit. So this pipe is running in the engine room. It covers near about 2 floors and reach in the BWTS room. So you can see this line is coming and entering in this EDU unit. So you can see a pneumatic control valve and this red orange color valve. And this is the flow meter. Basically it sends the flow rate. In this EDU unit, the electrolysis process will take place and it will generate oxidant, mainly your sodium hypochlorite and byproduct hydrogen. Hydrogen will be removed by the two blowers, and the electrolyzed water, basically your oxidant which is generated, it will be injected back to your ballast pipeline. So you can see from the rectifier unit the wires are coming and it is getting connected to this cabinet. You can see the bunch of wire and their connection in this EDU unit for electrolytic disinfection. So a high current near about 1200 or 1000 it goes. So after the electrolysis infection, from here this orange wall, the outlet of EDU unit comes and again it goes to a booster pump. With the help of this pump, this oxidant which is produced by EDU unit, it will go to your midship store, which is your BWTS room, which I have shown, and this is a pneumatic control valve. So from here this you can see MV401, which is deck house. This valve is going and this line you can follow, this red marking, this pipe is going straight away to your AFU. This is the line which is coming from the EDU. This connection is given to your AFU outlet, so the proper disinfection take place, and it is connected to the main ballast pipe to provide effective disinfection. Your hydrogen is separated by the cyclone and mixed with the fresh air using this blower, sufficiently diluted with the air to a safe level, and then released overboard using this vent, which sends our hydrogen intake or the percentage of hydrogen which is released. This is the hydrogen outlet which is present on deck, generally on aft, back side of the ship. It can be a starboard or port, but it is very heighted so that you will not intake it, it will go in the air. This electrolyzed, or you can say your processed water, is injected back into your main ballast pipeline. And after injection, and or you can say after the mixing of this oxidant with main ballast pipeline, we have a tapping of TRO, a sampling which is going to TRO, which sends the reading. And if the reading is in between this range, it will constantly run. So guys, based on your TRO reading during ballasting, if the reading is in between your range, the system will work in normal. And if the reading of this TRO is showing low, below this, your rectifier unit will give more current so that more oxidant will get produced, basically your sodium hypochlorite. So that this sodium hypochlorite go and mix with ballast water so that proper disinfection take place. So if the reading of this TRO is more, suppose rectifier unit is giving more current and more sodium hypochlorite oxidant is getting produced, this TRO reading will give feedback signal to your PLC, programmable logic controller. This PLC will give command to your rectifier unit to reduce the current so that your sodium hypochlorite or your oxidant will be generated less, and there will be a less mixing of sodium hypochlorite to your ballast pipeline. So basically we have to maintain this range of TRO reading. So this is a balanced process in which TRO sends the value, and based on the value the rectifier current is adjusted so that disinfection take place in a proper manner to meet the standard of IMO, USCG or other port state. So I hope ballasting is clear. Generally your AFU filter unit, your rectifier unit, your EDU unit, your all PLC, motors, seawater pump and your TRO, they comes in roll. So during ballasting all these things comes in roll, and many other valves and operations are there which is controlled by the PLC. Next process is your deballasting process. In deballasting process, basically we have water in our ballast tanks, so we have to throw them overboard. So before throwing them overboard, we have to dilute this oxidant. Your automatic neutralization unit comes in role, and your TRO. In deballasting process, your TRO continuously monitor your deballast water, the water which is going overboard. Its value should not exceed 0.1 milligram per liter, or it can vary from as per your port state requirement also. So if the value exceed more than 0.1 milligram per liter, your dosing of neutralizer will be more as per your TRO concentration. If your reading is maintained at 0.1 milligram per liter, the process will run throughout. In your automatic neutralization unit, we have this tank in which we fill up these gunny bags which contain Na2S2O3. So Na2S2O3 is mixed in this tank. It is used as a neutralizer. Automatic neutralization unit is used to neutralize the oxidant which is present in your ballast water. While ballasting, we have mixed the oxidant. So to neutralize those oxidant, we use this ANU unit, automatic neutralization unit. And in this tank, we mix this Na2S2O3 as a neutralizer. After mixing of Na2S2O3, NaCl and Na2SO4 are produced in your neutralization reaction. These are mild chemicals which will not pose potential risk to our receiving water. Metering pumps. Metering pump is used to pump certain amount of neutralizer sodium thiosulfate to react with residual oxidant to ensure TRO, total residual oxidant level, do not exceed the discharge standard for active substances issued by IMO or USCG or other port states. The dosing rate is controlled in accordance with TRO concentration in discharging water overboard and automatically adjusted by the PLC, programmable logic controller. TRO are basically your economical and low maintenance equipments. This equipment which is present on deck or your BWTS room, complete room which is there on the deck, they have to be explosion proof because wires are coming. So they have made this cabinet airtight, and this is the unit which sends the pressure. There should be a positive pressure inside this cabinet. So this is a unit which sends this positive pressure, and on top you can see the air unit which is connected with this cabinet. which is used to measure the oxidant which is present in your ballast pipelines by using DPD, chemical chloromatic method. In this TRO you will see two bottles are there, and these two bottles are connected with a small pipelines. These two bottles consist of reagent. One bottle contains the buffer reagent which control the pH. The second bottle contain indicating reagent which produces color for your chromogenic reaction. You can also see this green LED. This green LED provide the 515 nanomicro source lamp. Colorimeter compares chroma of sample water with reference standard to obtain measurement result. So guys, I hope you have got little idea about ballasting and deballasting using our ballast water treatment system. So it is a important equipment and you will find these equipments on ship. So you must know about them before you use them. During your deballasting, your cargo loading is going on. So chief officer has to take care of those tanks also which are getting filled with cargo. So all this BWTS system, they works in auto. This complete system is an automatic system. So you don't have to look or monitor continuously for something. You can run this system in auto mode and this will automatically sense your deballasting and ballasting process. If the values goes higher or lower, automatically it will control, and sometimes you shut your ballast pumps also. This system is big and it is like scattered something on deck and few things in engine room bottom and second deck also. So we do face problems, but not in a big scale. But there are minor problems which I have faced in this BWTS system, which I will cover in the next video, because I don't want to make this video very lengthy. Next video I will cover what are the problems which I have faced and routine maintenance which you have to do on this plant to run them smoothly. So guys, I hope that I was able to deliver you something. See you in the next video.